Good evening. This is meteorologist DT here with our Saturday evening, late evening uh, update video here on tropical storm Elsa. It was a hurricane, now a tropical storm, and what it might or might not mean for the Middle Atlantic region and the southeast coast. Let's get right to it. First, of course, here's our website, and you can take a look at the different forecast products that we have here for operational weather, including the new hurricane forecast will be out shortly. New hurricane product, which is really going to be quite unique and quite different. And don't forget, here at the bottom, you get the 3 week newsletter, a lot more detail on Elsa and what the rest of July looks like in the forecast update, which comes out Sunday late afternoon or evening. So, that's something to look forward to. Okay, let's get started here. This is the latest satellite picture here from Simus, and you can see that it has intensified. Well, it looks like it's intensified a little bit. We certainly have a large burst of powerful convection which has formed over the center. And also, if you read the 11 o'clock discussion, and obviously if you're tracking it by the recon planes, it has slowed down significantly, which is, not unexpected. Speed is now down to about 15, 16 miles an hour from the extremely fast 25 or 28 miles per hour it was doing yesterday and the day before. Now, what that slower forward speed means is that intrinsically reduces the shear. When you have a tropical cyclone that's moving that fast, it always creates its own shear outside of the wind fields in and around the tropical basin, the Atlantic basin, the Caribbean basin. Um, you typically will get areas of wind shear, but when the system is moving that fast, it almost always creates its own wind shear. And what happens is that the low level center simply outruns the convection, and you get a decoupling, and the system collapses or it struggles to survive. And clearly, that is what was going on with Elsa all day today. It was really struggling to even survive, but clearly it has now missed the southern tip of Haiti. You can see there, and the center has moved underneath the convection. Now, the latest information from the Hurricane Center says the pressure has not really dropped yet. So we don't know if that's actually going to happen. It has a chance to. We'll get into that in just a second. Now, this was a satellite picture from 2230Z. So that's it's 6:30 here Eastern time, and you can see it looked like crap. I mean, there was a bunch of convection there, but it was not blowing. I mean, there were blow explosions of it, little blobs of convection blowing up here. You can see that in the big white and black areas, the pink even more intense convection, but it was not that impressive. So obviously it has really, really picked up here in over time. So this here is the latest surface map. You can see it is now between Jamaica, eastern Jamaica, and the southern tip of Haiti, and it looks like it's going to go through the slot here. That means that the center is going to stay far enough off of Cuba for a little while longer, which could allow it to intensify back to a minimal hurricane. It's not out of the question. Now, it is going to hook into Cuba at some point, so there's no way of getting around that. But if it goes through the slot here between Jamaica and Cuba, then it's got possibilities where it could intensify a little bit. Now, this is the evening picture, so we can go back and compare the two here for 1 second. There was 6:30, and now here is the latest one. This is as of 11:15, and you can see it has really exploded here big time. On the purple lines there, I drew in the peninsula of Haiti and then the coast of the Cuba, so you can see exactly where it is. Here's the latest vortex data message, and let me see if I can blow this up here a little bit so we can follow a little bit. There you go, and you can see the pressure. The maximum flight level winds at 57 knots. And they found that in the northwest quadrant, and it's so that's not strong enough for hurricane force at all, not even close. The pressure, it's not that it's still doing not it's just not intensifying. So it looks better on a satellite picture. The eye wall, there's some warming. The eye wall, not a lot. It's a tropical storm. It's nothing to get that excited over. So we can take a look at some other data here. This is the latest flight recon, and you can see again And this is some tropical tidbits. If you look on the upper left here, you can see the blue line is the maximum flight level winds, and again, up to 50 knots. And the red line is the pressure, so the lowest pressure here is around 10 millibars. Now, again, you know, it's it's very high mean sea level pressure despite the winds. Usually the pressure is a lot lower than this, so that's interesting. Maybe it's got down to the lowest level on 1009. Now the surface winds, we're getting some blue dots here around 50, 55 knots, so 60 miles an hour at tops, no more than that. It looks like it should be getting stronger, but so far it's not. If we look at the wind shear, we can see that in the green areas, where all the Northwest Caribbean, there's no wind shear around. Very light conditions here. So the upper level winds are much more favorable for some intensification as it moves, south of Cuba, north of Jamaica into the slot position there before it hits Cuba. So again, the water temperatures in the Northwest Caribbean, 30, 31 degrees centigrade, that's 86, 88 degrees Fahrenheit. So there is some possibility for intensification here. The shear tendency, you can see there's no shear at all in and around Cuba, Jamaica, the Northwest Caribbean. So that's a good sign again. Now, this is the famous HWRF, and you see this in the social media, Twitter. A lot of weather hobbyists and other meteorologists, they love the hell out of this model, and I don't understand it. I don't think it's a terrible model, but I don't think it's particularly good. The problem with the HWRF is that it goes bonkers with any sort of tropical system. For example, now we know the pressure here is 1,009 millibars. We just saw that, right? Go back to that's the lowest pressure right here, okay? But this says that by tomorrow morning at 8 a.m., it's going to be 982 millibars. South of Cuba, off the Jamaica coast to the west of the Haiti Peninsula, right there. And if you think Elsa is going to be 982 millibars tomorrow morning, I got a bridge to sell you in Brooklyn. That's not going to happen. I would be very surprised if it happens. But the model just takes that, it goes bonkers with it, and I don't know why people think it's got a great reputation. I don't get it. I just don't. Now this is the 11 o'clock advisory. You can see they keep it a tropical storm all the way through. Then they eventually cuts across Cuba. Now the difference here is that before it looked like it was going to go over Haiti and then the length of Cuba. Here it makes a much shorter cut across Cuba, and then it goes into the southeast Gulf of Mexico, and then it cuts up the coast of Florida, and then across the northern Florida peninsula and along the Georgia, South Carolina coast, and then passing probably north of Hatteras, maybe over Fayetteville, Elizabeth City, Virginia Beach, and then maybe to Wallops Island. That's what the official track is, but that has a lot of variation to it. And there's a reason to think that that could change a little bit. You look at the latest forecast models, they show a general weakening trend here. They're not showing any intensification. Very few of the models showed getting stronger over the next 60 hours before it gets to Cuba. Now, this is the GFS from Saturday morning, the 00 okay? This is from early Saturday morning. Look for valid for Tuesday at 8 p.m. Look how strong the system, the GFS had. Let me blow this up, you can see it. Okay, it's 1,000 millibars. You see that? And that's for Tuesday, 8 p.m. That's what the GFS was showing just this morning, early this morning. Now, we look at the same time frame. It's barely an open wave coming off of the coast of Cuba. It's barely anything. And then there it is, this is 8 p.m. on Tuesday. Totally different situation. So, this weakening trend, this is one of the things that's bothering me about this system as it goes to Cuba and Florida and the southeast, is that the European hasn't showed anything with it, but sometimes the European can be twitchy that way with weak tropical systems. But neither does the British model. It doesn't show anything either. And now the GFS is showing this weakening trend as well. Now let's take a look at the upper air pattern and find out what's going on with this system. So this is the upper air map. This was valid on Friday midday, 12:01. And down here in the lower right, this little doohickey right here, this is, you can see it right here. This is in the lower right corner, that purple dot, that's Elsa. And there's the ridge. You see the orange blob north of it, north of Puerto Rico and the southwest Atlantic? That's the ridge that everybody was talking about. So it's going around the ridge, and here's this monster trough coming in. This is a big trough on the east coast for July. You can see that. And that there it is. Now that big red area in the middle of the map of Canada, that's the heat dome, which brought the extreme record-shattering, life-threatening heat to British Columbia, Alberta, Pacific Northwest, a few days ago. That has now moved into central Canada and the Canadian prairies, and those guys are cooking. But we do have a monster trough here, which is the one brought the nice weather today on the East Coast. I mean, it was just spectacular up and down the East Coast for early July. And it's going to be again tomorrow for July 4th. So we have that looking for us. Here is the map here for this afternoon, the Saturday evening, afternoon. And you can see the deep, deep trough. Look at that purple area over Virginia and the Delmarva. That's extremely negative anomaly here. And there is Elsa right by Haiti, approaching Jamaica. And what's going to happen is this trough is so deep, it's going to turn the system sharply to the north. So that is no doubt that's going to happen here. This trough is just too deep, and the system is already too far north. So the distance between the base of the trough and Haiti is like 10 millibars. 10 degrees latitude is what I mean to say, and that's just too close. It is going to turn it. And it does that. You can see what happens here. Now, this is valid for the morning of July 7th. The system is barely even recognizable anywhere near Florida, as you can see. And then actually, I put that map in a sequence. This is January 4th. This is tomorrow afternoon. Sorry about that. And you can see there's the trough. Now look at the piece of energy hanging back here over the blue area of Florida and Georgia, Mississippi, Alabama. So a piece of the trough hangs back there, and that pulls the system northward. And then and you can see. Let me go back here. And then there it is. I mean, it just falls apart. It's not barely even recognizable over the northern Florida. It completely falls apart. So that's why the GFS is weakening the system completely. It's gone. And by the time we get to the morning of July 8th, it's barely even something over Cape Hatteras. And this big new trough coming down across the Great Lakes is kicking it right out to sea very quickly. Here's the British model. Okay, this is for Sunday evening. Just a little wave over Cuba. It's nothing. I mean, it's completely wiped out the British model usually does very good, with tropical systems. And here it is now, Tuesday at 2 a.m. over the west tip of Cuba. Okay, there it is Wednesday afternoon, July 7th, in the Big Bend of Florida as I guess, a tropical depression or tropical storm. And then it's over Elizabeth City early Friday morning. Essentially a big rainstorm. Once it comes inland Florida, Georgia, the Carolinas, North Carolina, Eastern Virginia, it's just a rainstorm, folks. It's not going to be that big of a deal. Now, maybe there might be some, tornadoes as the system breaks apart and goes over land. The friction causes some spin-up tornadoes, but other than that, it's not a big deal. Here is the European. I mean, there's barely something on the European early on Wednesday morning at 2 a.m. near Tampa, as you can see. And then on the European, it cuts across there. Now it's southeast of Charleston on Thursday morning. And here's the hurricane models. And now this is the 12Z run from Saturday, July 3rd. Look, you can see the turn over Cuba, the west coast of Florida, or over Florida, then right along the coast. Most of the models have it passing, I guess, north and west of Hatteras. A few of them take it off the coast, but most of the models take it either Hatteras, north and west, right along the coastal areas. So what this means is that as the system goes into Florida and along the southeast coast, the Georgia, the Carolinas, if you're just inland, the friction is going to rip the hell out of this system. So there'll be almost no weather at all on the western side of it. So all the massive convection, the thunderstorms, the windy conditions will be on the eastern side on the coastal areas, just inland. So in other words, if you're, let's say, in Raleigh, you could have a lot nicer weather conditions, just some rain, and all the wind could be, let's say, in Fayetteville or in New Bern or Morehead City or Hatteras or Wilmington. So the same thing like in Richmond versus Norfolk or Virginia Beach. Big differences there. And then, so that was the 12Z run. Here's the 18Z run. Not much difference, you can see. Very similar indeed. It looks like more of the models are taking it further to the west of the Florida coast. The one difference is that here you had more models going right through Florida. Now you have more 18Z, you had more off the coast of Florida. And then as we go into, this is the new one, 0Z July 4th. Look, almost most of the models again take it into the Big Bend of Florida, up by Tampa, maybe a little further up the coast, but then across northern Florida, right along the coastal areas again. Again, notice that most of the models have it just inland and passing north and west of Hatteras, probably right through Fayetteville and maybe Elizabeth City to the east of Raleigh, and then very close to Hampton Roads. As a rainstorm, a little windy conditions, not a big deal. It just is not going to be that big of a deal. But it is an unusual system in that saw a hurricane here in early July in the Caribbean and in the Atlantic, which is not a very common event. And of course, to get the E storm, the fifth named storm of the season, this early is really quite remarkable. Anyway, that's my forecasting presentation. I'll have more information in the 3-week newsletter. This is meteorologist DT from Weather Risk. I'll see you over on the Twitter page and over on the website.